So continuing where we left off from last week, this week we'll be talking about cProfile. It's a module in the Python standard library which provides a granular breakdown of where CPU time is being spent. In last week's screencast, we talked about various types of timing, while we actually didn't get into the profiling portion of the talk. We're going to focus that on that more today, and we're going to show you a few ways to visualize it and things you should avoid when dealing with profilers, and a few spots about calibration and what you should be aware of when trying to improve your application for speed. So I've taken the liberty to drop a small example. As you can see here, we have three functions called delay, which each call time.sleep with respectively 1, 2, and 3 seconds. We then call each of those in sequence in the main method, and then we return a cProfile. This is how you run a profile programmatically in Python. Most applications won't be as clean as this because right now we have a clean entry point, but when you're profiling things like web applications, for example, it won't be as easy, or you're trying to profile how long or how fast you want to get a database save or something going on. You won't be able to simply go run a web app and then profile the entire thing and then be able to pick out which portions you want to look at least not easily. So I'm going to show you an example of how to run cProfile programmatically. We're then also going to take a look at the output. So with this example, I hope to clearly show what each portion and part of the application does and the output profile, so you can then use that to grow to understand larger, more complex profiles. So let's take a look now and run the profile that we have here. So we're simply just going to go Python slow.py, which is the file that this code is written in. I'm gonna run it. Just give it a few seconds. So awesome, it ran. So the first thing you'll see at the top of the profile is the number of function calls. So there were 9 calls. So as you can clearly see here, we have one function called to delay, and another function called to sleep, another function called to delay 2, another function called to sleep. So you'll have 2, 2, 2 here, which is 6, and then you have the function called to main, and then sleep 3 times, and then you'll have each of the calls to the delays, and then the main method. So that'll give us a total of 9 calls, which you can then account here. So you have 3, and then you have individual calls to each one of those, and that's a breakdown for each particular call. So you can see here that sleep was called 3 times, delay was called once, and so on. So that's what the end calls row does. Now the total time row is the total time without subcalls. So for example, our delay method, all it does, it goes into, so let's take for example the delay number 1, which is on line 5 of slow.py. Total time is the time that it has taken without subcalls. So without counting the subcalls, how long did this particular call take? So as you can see, it took nothing. It's simply we call delay, then it immediately calls time. So total time is time without subcalls. Now per call is total time, which is time without subcalls, divided by n calls. So 0 divided by 1 is still 0. That makes complete sense. Cumulative time is the time with subcalls. So slow.py line number 5, delay function delay 1 called sleep.time1, which took 1.00 seconds. So that was the time with. So it'll show us 1. And then per call is the cumulative time divided by number of calls. So 1 divided by 1.001 is 1. And that's generally how everything works. So as you can see here, sleep had a total time of without subcalls of 6 seconds, 2 seconds per call. So it averaged out to 2 seconds per call. So we called once with 1 second, we called once with 2 seconds, once with 3 seconds, all that divided by 3, which is 6 divided by 3 is 2. That's per call. Our cumulative time is the total time spent in the sleep function with subcalls, which is 6 seconds as well, and then divide that again by 3 to get you the per call time. And then the last row here shows us where the function was called. So line 13 of delay.py shows that delay 3 isn't defined there, and then that's the function. So that gives you an easy way to pinpoint where a particular profile is, so you can then pinpoint it and then see. So you may see some things here that aren't actually being profiled. So as you can see here, there is a string thing. You'll see things like these throughout the thing, really not worth commenting on. You just need to understand that they are artifacts that get thrown into the mix when profiling. You really need to be more concerned about what you're trying to create or make faster. So for the remainder of this talk, I'm going to be using a simple decorator that will decorate any function or particular thing we'd like to profile, and will print out a dump to a file from where that path is invocating. So this thing can come in handy when you're trying to profile things in web applications to see how fast a particular function is, or a group of lookups or a group of calls. All you do is write a profile that's simply a decorator that takes a function, creates a profile, runs the profile, and then dumps the stats for that profile to a path in some name that you passed. In this case, you can give it a name, you can pass it as an argument to the profile name. In this case, we just take the function, the name of the function plus .profile. So as you can see here, we reworked our example that we had previously that had cProfile run here. Now we just decorated the function that we wanted to profile with profile this. I've already run this, so if we go ls here, you'll see that we have a main.profile in the directory here. So let's just pop into Python. Let's go import pstats, and that is a standard library again that's in the standard library of Python. Then we'll go p is equal to pstats.stats. We will then load the main.profile. Since we invocated the Python executable from that directory, we can just refer to it by its name since it's in the main there. Then we'll go p.print stats, and then we'll print the top three stats. So as you can clearly see, we have the top three things here. Since we didn't specify an ordering type, it's just random, so these have actually no meaning. In order to sort them, what you need to do is to go p.sort stats and then sort them by what you're interested in. So I'm interested in time currently, so we're going to pass time as an argument to the sort stats. So we're going to go time, and sorry about that, the screen's messing up, but resize the window, and then we go p.print stats, and then we're going to print the top three, which then shows it's ordered by internal time. We see that the top three stats are called. Now, as you can see here, and this is a distinction that will start to become clear as you use profile more and more, that these two are taking the most amount of time, as in cumulative time, and that's what we're ordering by now, internal time spent inside the function. So you'll see that both main, since it was called once, the cumulative time in main is 6 seconds, but as you can see, the cumulative time was also 6 seconds for the sleep, but it was divided over 3 calls. So you'll see that sometimes things are repeated, but to understand the nuance there. So there's not much optimization we can do in main here, because it simply calls delay 1, delay 2, delay 3, but, and this is an example, if sleep.time could be modified to be faster or better, this is where our improvement would come from, not from the main here. And you'll notice that this does not drill down any farther because it's part of the standard library. There's not much you can do there, but you can drill down using other applications to see what's actually running. I think sleep might be a C thing, so I'm not totally sure there, but for other things it's definitely possible. So we've just loaded a profile created by a dump, which is very useful. You can pipe this into other visualization tools, which I will show you next. Now that we've learned how to profile particular parts of an application using the profile this decorator, as well as programmatically creating profiles, as well as dumping those profiles to a file and then reading them again programmatically, we can now rely on some tools that give us a little bit of extraction and allow us to more easily consume and visualize the data that's in that particular dump. There are a few tools for this. Today I'll be talking about SnakeViz, which is a D3.js implementation that accepts a profile and then graphs it in a web application. Another popular desktop GUI is Run Snake Run, which is, in my opinion, a much better one and more well developed and fleshed out. Unfortunately, it's very annoying to get up and running on OS 10. I've wasted enough time trying to get it running. I believe it's fairly easy to get running on Ubuntu, so I would definitely take a look at that. But today I'm gonna show you SnakeViz. So using the previous example that we had before with the main.profile, we're simply going to go SnakeViz main.profile, and that'll pop up a window that contains the profile that we had previously. So as you can see here, it's the same old profile I've been working with all day with the sleep and the slow. What it does though, it visualizes it for you so you can see where a lot of the time is being spent. And the way that this works, unfortunately, I would prefer for it to be able to take each of the rings and have them ordered by time. So the thing that takes the most time would be in the center. Unfortunately, it organizes it, I believe, by the type of call it is and where it's being invocated from. So as you can see here, our main is the thing that we're running, and then we have the 3 delays here. So as you can see, the 1 second delay is here, and then the 2 second delay is here, 3 second delay is here, the main is here, and then all the time spent in the thread is here per call. And that's how SnakeViz looks. It's very cool. We can do a sunburst, or is it the only type? You can see the JSON outputs for it, so you can show the localization per, and you can get all that information. So it's just a JSON file that's loading up, and that's SnakeViz for the part. I believe there are plugins that get different visualization types, which can be cool. This probably isn't the best one for our particular application, but this and Run Snake Run are some pretty cool visualization tools. Now, this one just shows everything up front. What Snake Run Snake does is allows you to drill down into particular portions of the application in order to expand to see where the time is being spent. So it'll be organized by size, and then you can go ahead and click it. Maybe we can just bring it up. Run Snake Run. Here it is. So as you can see here, Run Snake Run has different portions. So this looks like their profiling GUI application or OpenGL context, and it shows you where all the big pieces are. So if you're interested in polygons, it'll highlight that. As you can see there, it's highlighted in lime green along the side. You can then drill down into that and to see which particular portion is taking the most time. So you click that, that would become the main one, and then so on and so forth. So I highly recommend Run Snake Run. Now let's look at more of a real life example. We're going to use SQLAlchemy here. You don't really need to know how this particularly works. Just believe that I am dropping tables. When I drop them, I created an instance of a user, which gives it in a user's table name. It takes a name and an ID, and then all we do is we create the engine, a connection to the engine, and we pass the session back. This is the initialization portion of the database creation. We aren't interested in profiling this. It's relatively fast, and improving it really doesn't really matter. We need to improve things that we're going to either do often or things that we think we can improve the speed of. Now, for this example, we're going to be adding 1,000 users to the database. Let's just say we want to pre-populate our database with some fake data. We want to move forward. Now, in this particular case, all we're doing is creating usernames with user number within the X range of the number I pass in. We create a session. We iterate over the usernames. We create a new user each time we do it. We add the user to the session, and then once we're done adding all the users, we commit. Now this is the way we do it. It runs. It's all there. And then here we have the function. We create a new DB, delete old DB, create a new DB, create the table, and then we add 10,000 users. Very straightforward. We're interested about how fast can we get this adding users to the database. That's what we want to profile. We again use the same profile decorator that we had from before. It should dump a file called add users ORM to the same directory that we run the application from. So let's go ahead and run that now. Let's go Python create users. Excellent. Excellent. So we now have a profile that we can then load up with SnakeViz. So the name of the profile will be add users ORM profile. Awesome. This may take a second to load up the graph, but while that's happening, we can take a look at how to go about figuring out where the time is being spent. Now, if you remember earlier, I went and described where total time means, and that's the total time without subcalls. So if we arrange by that, we get to see that the execute method, so total time without subcalls, that means it will not give you the time back for anything that it calls, but it'll give you the time that is spent inside that particular function. So in order to determine where the time is being spent, you want to be able to organize your times by total time. So we clearly know that we're trying to create 10,000 users, and the total time spent in the execute method of cProfile, which is the cProfile 2, which is the Python bindings for Postgres. The execute method, we're spending 2 seconds, a little bit over 2 seconds inside that function. So we know that's where we need to focus our improvements. Now, there's a lot of internals to databases, but one thing I know is when you don't pass in or you tell the engine to create users, it assigns an ID, and it needs to look back at the previous ID each time it wants to create a new one because it's auto incrementing. So let's say I add one user with 5, then the next, it has to go, before it saves the next user, it has to go check to see, okay, what was my last user's ID? That's 5. Okay, this one should be 6. So that turnaround, I know, takes a little bit of time. Maybe we can do something there. Maybe. But before we do that, I want to take another look at cumulative time. Now, if you arrange by cumulative time, and our function that we called last time was create users.py, the add users ORM method, which is where everything is happening, it took about 5 seconds. So we need to also, when you're profiling, you need to make sure you understand how long everything's taking, and then you need to understand what within that whole process is taking the most time in order to know where to focus your efforts when you're profiling. Here it is clearly the execute method, the cProfile method function. This also might have to do some layer interaction for SQLAlchemy. So a thing that I do know about SQLAlchemy is that when you want to bulk add, that whole process of going to look up the ID can be straining to the engine, and it forces it to behave a certain way. But if we provide the IDs up front, that may cause for a little bit of a speed up and an improvement, and may even cause cProfile to do something else. So let's go ahead and set that up. So new user.id is equal to I, and here we're going to go enumerate, and this is a pretty cool Python function. What it lets you do is get a list of your output your list. It'll give you the index in which you're at and the thing that's in that particular position. So when we call enumerate, it returns a tuple of I and I being the index, name being the item that you have there, which is the name that you want to save the user for. So this will remain unchanged. I will be the ID there. We then add the user, and hopefully this will show a little bit of improvement when we run the profile again. So we're gonna close SnakeViz. We are going to run create users.py one more time. We are then going to run the visualization one more time. Again, this will take a few seconds to load. Okay, more than a few seconds to load. Awesome. So we have everything running. As you can see here, the center is still the add users ORM, which took 3 seconds now versus the 5 seconds it took last time. So we've improved our performance by 2 whole seconds by simply removing the auto increment requirement that the database engine needs to do by pre-providing the index for each of the users. So now let's go and see where the time is being spent. Oh, so as you can see here, it's being spent in the execute many function in cProfile 2, which it used to be, from our previous example, it was in the execute many for 2 seconds, but it is now in the execute, it's in the execute for 2 seconds, and it is now in the execute many for 1.5 seconds. But another thing that you need to keep an eye on is the fact that this was called 10,000 times. So as you can see here, last time it spent 2 seconds calling this function 10,000 times. So dividing that out will give you per call. But as you can see here, there's only one call of execute many to psychophagy, which the total time of 1.6 seconds. Divide that per call, which is the total amount of time. So that caused a shift in the way SQLAlchemy was behaving in order to store the things. It took advantage of the fact that we were pre-providing the IDs, which then led us to a faster bulk load of all those users. And this is generally the process you take when trying to profile anything. You would measure a particular portion that you're interested in, see where the time is being spent, see what's actually happening. This is often leads to better understanding of what's actually happening, and then it leads to you to understand what things are doing, and then maybe take advantage of those capabilities. Visualization tools like Run Snake Run and Snake Viz are very useful when you need to visualize how things are happening and you need to understand where things are and how they work together. And tools like cProfile provide you that granularity you need in order to be able to accomplish this level of testing.